We're going to look at the first lesson, which is descriptive statistics and data organization. Under descriptive statistics, we're going to look at group data and ungrouped data. So whenever we're dealing with ungrouped data, we're looking at data parameters which are disorganized, like you can see here. You need to arrange them on your own. But before I go in depth in looking at the parameters we're going to measure, this is what is called group data, where you classify your information in what are called classes or clusters. But we'll go to our grade 1 and firstly identify what are called pictograms. So we have pictograms shown A, B, C, D up to I, and I'll ask you to identify whatever you are able to. What is A? What is B? What is C? D, E, F. Can somebody identify? A is what?
That's a pie chart.
A is a pie chart. B?
B is a bar chart.
It's a bar chart, yes. C? Anyone else? What is C? Let's start from what you know before we go to complicated stuff.
A histogram.
It's a histogram, correct? What is D? An or give, it's joining the points, midpoint of the histogram. What is E? It's a cumulative frequency graph. And F is a relative frequency polygon. G and H, this is a bar chart and histogram, but they are coming from this angle. We have a pie chart or a donut. So at least you're able to identify these on your Excel sheets. Data presentation is important whenever you're presenting or summarizing data in pictures. So now we're going to look at what we call ungrouped data. You could be given information as follows. You have 3, 4, 4, 6, 5, 7, 10, 20, 6, and maybe a 4. So this data is called ungrouped data. The first thing you need to do is rearrange it. So when you're rearranging it, starting from the biggest number to the smallest number, let's arrange together. What are we going to have?
20.
From the smallest, we start with what? 3. Then
4.
4. Then another 4. Then 4. Then 5.
5.
Then
4.
6.
5.
6. And what? 7, 10, and 20. How many are they? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So we are going to now calculate what is called the range. So there are measures of dispersion and measures of central tendency. So we're going to start with measures or mix them. Measures of central tendency really look at the data that is collected in the middle, like the mean, the median, the mode. So let's start with the range. The range is the difference between the highest number, which is x max, minus the smallest number, which is x mean. So what is our highest number?
20
Minus what?
minus 317.
Our range. Half of the range is called the mid-range, although it's not very commonly pronounced, but I just want to measure all the parameters. So the mid-range is half of the range, or half of 17. What is half of 17?
8.5.
8.5. Then we go to what are called quartiles. We have the first quartile, which is the first quarter. We find the quarter of n plus 1. N is the number of parameters we have. We have 10. So we have our n as 10. So whenever we calculate, 10 plus 1 is 11. What is a quarter of 11? So if the answers you get, for instance, you get 2.25, you round it this off to the nearest whole number, which is 2. We get 2.75, round it over to the nearest whole number, which is 3. At 2.5, you're going to add the second number and the third number. Then divide by 2 to get the median. If you have 7.5, you get the seventh number and the following number, which is 8, divide by 2. All right, so what is a quarter of 11? What is a quarter of 11?
2.75.
So we're going to round off this one to what?
To 3.
The third position, yes. So what is the third position here? 1, 2, 3. So this is called our lower quartile, which is Q1. So what is Q1?
4.
Oh, good. So Q1 means what? The lower quartile or the first quartile. Q2 means the second quartile or the median. So for the median, it is half of n plus 1. So n plus 1 is 10 plus 1, which is 11. So half of 11 is 5.5. Can somebody tell me what did I say? What do you do when you have a 0.5?
So you get the fifth number and the 60th number and divide by 2.
Excellent. The fifth number which is appearing there as a 60th number, divide by 2. These ones give you the position. So what is the fifth number? Count. 1, 2, 3, 4, 5. And the sixth number is 6. So when you add 5 plus 6, coincidentally, the positions are even showing the numbers themselves. Not always the case. So we're going to get 5.5. So our Q2, which is the median or the second quarter, is 5.5. Then our Q3 is the upper quartile, which is a quarter of n plus 1, 3 quarters of n plus 1. our n is 10. 10 plus 1 is 11. What is 3/4 of 11? What is 3/4 of 11? I hope you have your calculators nearby quickly. What is 3/4 of 11?
8.25.
8.25. Good. So we round off this to the nearest what?
Or number
Which is what?
8.
8,
8th position. So which one's our 8th position here?
7.
7. Great. Then the difference between the upper quarter and the lower quarter is called the interquartile range. So the upper quarter is Q3. The lower quarter is Q1. So when you subtract Q3 minus Q1, we get 7 minus what? 7 minus 4. So we get a 3. This is called the interquartile range. And when we have the interquartile range, we call that the quartile deviation, semi-quartile deviation, SQR. Half of the interquartile range, so half of the 3, we're going to get 1.5. Any questions this far before I proceed? Is it clear?
Please go through the first quartile. I missed it. Kindly, thank you. How to get that?
First quarter, it's a first quarter. So Q1 is simply a quarter. Q2 is simply half. Q3 is simply 3/4. So our first quarter is simply a quarter of n plus 1. So our n in this case, as we added them up, our n was 10. So 10 plus 1 is 11. A quarter of 11 is 2.75. You round off this to the nearest whole number, which is 3. The third position, 1, 2, 3, is 4. So this is our Q1. Our Q2 is a median for the second quarter. Half of 11, which is 5.5. You add the 5th and the 6th, 11 divided by 2, which is 5.5, coincidental. So this is our Q2, which is our median. Q3 is 3/4 of n plus 1. 3/4 of 11 is 8.25. To the nearest, we get 8. The 8th position, you're going to get 7. The difference between the upper quartile and the lower quartile, it's called the interquartile range. So this is giving us what? A 3. Half of this one is called our semi-quartile deviation. So this is how we do the computations. Anyone behind so far? All right. Is that clear, Gloria?
Yes, it is. Thank you.
So now we go to what we call a box whisker diagram. A box whisker plot has 5 important summary points. You need to have the lower bound, the x mean, and the x max.
Hello, would you be able to share that recorded the class after the class?
Yes, I will. Like I said, I've shared.
Yeah, please, because I'm somewhere whereby it's very hard for me to concentrate because I'm driving.
All right, no problem.
All right.
So we have the minimum value of x and the maximum value of x. So what was our minimum value of x? It was 3.
3.
Our maximum value of x was what? 20. Then the first quarter. So here we are 3, 20. First quarter had 3,
It was 4.
4. Okay. And the upper quartile was 7, and the median was what? 5.5. So 4, 5.5, and 7. This is Q2, Q3. So we could draw the other. So our 4 is here. That is 4. Then we have a 5.5. So this is our Q1, our Q2, 5.5, and our Q3, 7. The difference between this and that is called the interquartile range. Our interquartile range was 3. So this box whisker diagram, we can help us to find the outlier. We multiply 1.5 times the interquartile range. 1.5 is part of the formula. So the interquartile range, you multiply the 5 to that one here. 1.5 times 3, what we get? 4.5. So this 4.5, you add it on the upper bound and you subtract it on the lower quartile. The first quartile, you subtract 4.5, you're going to get negative 0.5. The upper quartile of Q3, you add 4.5, you're going to get what? 11.5. So any numbers outside these two ranges is called an outlier. An outlier in layman's language is the odd one out. Which numbers are out of this range? We have 20. So 20 will be called our outlier. So you go and check on the list there, which one is above 11.5. If there was any other number, it would have been an outlier. So 11.5 is somewhere there, 0.5 negative is somewhere there. So the numbers that are not captured within this range are called outliers. It is important to understand the concept of outliers because it helps you identify the old ones out. Very important principle. So now we need to go and total up. So 3 squared is 9. 4 squared, 16. 16, 16, 16, 25, 86, 86. 7 times 7, 49. 10 times 10, 100. 20 times 20, 400. So you need to total up here, total up there. The total of this column is called summation of x. The total of the other column is called summation of x squared. Be kind enough to calculate the totals for me there. What is the summation of x and what is the summation of x squared?
The summation of x squared is 703. Perhaps someone can confirm.
Okay, 703. The summation of x.
And summation of x is 69. Someone can also confirm.
Right. So believing that those are the correct figures for the sake of time, if people don't want to use a calculator, summation of x is what? 69. Summation of x squared is 70.
703.
And our sample size n was what? 10. So we're going to now calculate the parameters. There's what we call the mean, which is x bar. The mean is summation of x over n. The mean is also called the average. So summation of x, this is 69. Our n is 10. So here we're going to get 6.9. The variance is given by summation of x squared minus summation of x to the power n, everything over n minus 1. So 703 minus 69 squared divided by our n, which is 10, everything over 10 minus 1. What are we getting? So you start from here, square the 69 squared over 10, then the answer subtract from 703, then you divide by 9, which is 10 minus 1. So 69 squared divided by 10, 703, and that's the answer. You get 226.9.
Divided by 9 is giving 25.21.
So you're going to get, yes, 25.21. That is called the variance. When you square root the variance, the name is called standard deviation. So square root of 25.211, what we get? We're getting 5.02. So the x bar stands for the what? For the mean. The sigma squared stands for the what? The variance. The sigma stands for the standard deviation. When we square root it, the variance becomes the standard deviation. Then we have what we call the coefficient of variation. coefficient of variation. The coefficient of variation is simply CV is equal to standard deviation over mean times 100. So our standard deviation we already calculated just now as 5.02, and our mean is 6.9 times 100. We get a percentage. What are we getting? 72.77%. So this measures the degree or the extent to which your data sets are deviating from the mean, from the middle. Although you not be asked to interpret at this stage. Then the mode simply stands for the most frequent number or the highest frequency. So when you go back to your data set here, you discover that which one is appearing the most? The number 4. So 4 is your mode, it's appearing the most. So far, before I proceed, any questions? Where you're behind, please ask.
I think I just need clarity on that part where you were multiplying the semi-quartile deviation and the interquartile deviation. That's what you did
Okay.
when finding the, I don't know what you called it, but then when you found 4.5, that part.
How did you find the 4.5? So standard deviation after calculating,
Not the deviation, before that.
I go to the previous page.
Yes, here, right there.
So to find the outliers, you simply subtract the lower quartile and as 1.5 IQR. The lower bound, then the upper bound is 3 plus 1.5 IQR. So our IQR was what? 3. So when you multiply 3 times 1.5, you get 4.5. So to the lower bound, we subtract the 4.5. That's what gave us what? The 0.5 negative. Then when you multiply the 3 here to the 1.5, what we get? We get a 4.5. When 4.5 you add it to the upper quarter, the 7, we get 11.5. So this helps you identify which numbers are outside this range. We found 20, and that is our what? Our outline. Clear?
Okay.
All right. So can I proceed? So now we have calculated our mode, we have calculated our coefficient of variation. The last calculation is what is called coefficient of skewness. Skewness simply tells you the degree to which your distribution is bending. When you get 0, it is normally distributed. When you get a positive number, it is skewed to the what? To the left, or it's positive. When you get a negative number, it is skewed to the left, or it's negative. So the formula for skewness is 3, the mean minus the median over the standard deviation. So our mean was 6.9. Was it? When you go back to our data, our mean was 6.9. Then our median, we had calculated the second quarter was 5.5. We put 5.5 here. Then our standard deviation. That is a standard deviation. We just calculated it as what? 5.02. Already, when you discover that your mean is greater than your median, you get a positive answer. So you say it is skewed to the right. You get 0 point something here. When your mean is less than the median, you get a negative, it will be skewed to the left. So in an actual perspective, you would want to find out how does the coefficient of skewness help me. You would be able to tell, for instance, if more people pass QM, you get a positive skewness. If you get a negative, less people, you would say less than 50 passed. So now, any questions at this point before I proceed?
Yes, is the 3 part of the formula?
The 3 is part of the formula, yes.
Okay.
So I'll send you questions following up this, all right? I usually give questions from the tutorial sheet so to acquaint yourself. So I'm done with grouped data. Go to grouped data. We have class interval. Our next class will be on Tuesday. The number of groups I'm attending to. So those of you who will be consistent will move together. I'll send you recordings. Don't miss anything. Those of the colleagues who are still speculating, there are a lot of tutors out on the ground, so be careful. Ours will just be to advise. All right. So please, ultimately, it is our aim that all of you pass. So from wherever you're learning, just make sure that you get the right materials and you learn what ought to be known. So we have these intervals, 20, 5, 30, 35. So this starting at 11, we have 16, we have 21, we have 26, and we have 31. So maybe we have 1, 4, 7, 10, 6, 3, 2. Okay. So you'll be asked firstly to draw a histogram. So whenever the classes are not adjusted like this, you already know that the histogram needs to have attached classes. So the rule is you subtract 0.5 here and you add a 0.5 there. So this is 0.5, 0.5, 0.5, 0.5 until the end, 0.5. All right. So the histogram has bars that are attached. So meaning here we're going to start with 0.5, and this becomes what? 5.5. We're subtracting a 0.5. It's a rule for them to be attached. These numbers must be the same because this number and that number are not the same. Okay. So we have 10.5 here. We have 15.5 there. We have 20.5. We have 25.5. And this should be 30.5. The upper bound, we are just adding a 0.5. So this is 0.5, 0.5, 0.5, 0.5, 0.5, 0.5, 0.5. So whenever we're drawing a histogram, cross here to say we're not exactly starting from 0. So we have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So we have 0.5 to 5.5, 10.5, 15.5, 20.5, 25.5, 30.5, and 35.5. So our height, the highest is 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So from 5, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So from 0.5 to 5.5, it's at 1. We do it at 1 here. Then at 4. Then at 7. Then at 10. Then 6, 3, 2. 6, 3, 2. So here you put frequency. And here you put the class. This is very important to know. All right. Any questions before I proceed on how to draw the histogram? Any questions?
So for now, do we ignore the 5.5, 10.5, 15.5? We just concentrate on the 0.5 and the frequency numbers?
Yes. 0.5 to 5.5. 5.5, I've just adjusted them. So
Yeah, I know how we've adjusted, but I've seen on the histogram, we haven't yet we haven't included any of the 5.5, the 10.5, the one that we're adding
they're here.
the
0.5 to 5.5, 5.5 to 10.5, 10.5. These are the ones right
no,
here.
I've seen that. Okay, no, I understand what you're trying to do.
Because you only adjust, especially when you only adjust when you see the numbers are not coinciding. If you had a number like 0 to 10, 10 to 20, 20 to 30, here you don't adjust because why? Because the number is already the same here. But here we are 5, 6 to 10, 11 to 15. This is a bar chart because there's a difference of 1 there. That's the reason why we're adjusting. But if it comes already adjusted like that, you don't need to do the 0.5s.
Okay.
All right.
Yeah.
That's clear.
Yes.
Okay, can I proceed?
Yeah.
Yes.
All right. So now I will want to expand what is called the frequency distribution graph. The frequency distribution graph. So here is what we call the cumulative frequency. So we add on. So we start with the 1, add to the 4, we get a 5. Add to the 7, we get what? 12. Add to the 10, we get 22. Then 2 plus 6, 28. 28 plus 3, 31. 31 plus 2, 33. That is the total we have here. Summation of F is 33. Okay. So now we calculate two things. Number one, the mean, the median, and the mode. So I'll start with the mode and the median. I said the mode is the highest frequency. So which number is the highest here? 10. We'll put our FM here. F1 is the number above. F2 is the number below. Then the lower bound on the FM, you look at the lower boundary. That is your L. I repeat, how do we find the mode? In the previous one, group data, we simply say the highest frequency, that's all. But here you need to find the exact one. So you go to the highest number in the frequency, you call that FM. Above it, F1. Below it is F2. In the classes, the lower boundary is L. Then to find H, the height, you just find the difference between this one and that one and that one. So our height is 5. Or our height is the difference in the class we did. 5.5 minus 0.5 is still 5. But if you didn't adjust this one here, it's safer to find the difference between the boundaries, because here we had 5, we had 0, we had 1, sorry, and here we had 5. If you get the difference, it will give you a wrong answer, which is 4. Why? Because you didn't adjust it. So it's safer to find the differences between the boundaries, either the upper boundaries or the lower boundaries. So 5.5 to 10.5 is still 5. So these differences there, they'll give you the height. Can I proceed?
Yes.
All right. So now we shall go to finding the mode. I said the mode is given by what? L plus FM minus F1 over 2FM minus F1 minus F2 and the height. So what was our L? We'll go behind here. Our L was what? 15.5. Our FM 10, F1 7, F2 6, H5. So our L 15.5. Our FM 10, F1 7, F2 6, H5. So here we're going to have 15.5 plus 10 minus 7 over 2 times 10 minus 7 minus 6 times the height of what? Of 5. So that is how this goes. Any questions? So for the median, what you calculate is L plus summation of F over 2 minus FC over FM times the height. So the FC is just adjacent to the F1. So this is our F1. This could be your FC. So FC is what? Is 12. I repeat, before I proceed, how do we identify the mode? What's the first thing we do, and what are the parameters we identify? Esther and Gloria. What do we do? Not Gloria. Number one.
Please repeat the question.
How do we calculate the mode? What do we do? The first thing.
You identify the highest, what, the highest frequency? Then you identify the frequency above the highest frequency as F1, and the frequency below the highest frequency as F2. Then you find the lower, what's it called? Boundary, is it lower boundary, which is 15.5 of the frequency, which is 10, isn't it?
And our FC is just adjacent to that F1, which is 12.
Yeah.
Excellent. So what remains is simply substituting. So how did we find S0? How did we find our height? How do we find the height? S0? Robbie, Nessa, how do we identify the height?
The difference between the boundaries.
Good, the difference between the boundaries. That is how we find our height. Alternatively, if you've adjusted the classes, it's the difference between the upper bound and the lower bound. Is that clear? All right. So after having found that, so our lower bound here will be 15.5. Summation of F was 33. So 33 over 2 minus the FC, which is in this case 12, was facing our F1. It's often the case over FM. Our FM is what? 10 times the height of 5. Then you calculate the median. Be sure or be careful not to abrogate board mass rules. So make sure you sort out the issues here. For instance, this is 10 minus 7, which is 3, and 10 times that minus that. The answer is multiplied by 5. That's when you add it to 15.5. All right, I don't want to feed you on that. I will send you the videos on this lecture with including this very one. Okay. So lastly, how to find the mean, how to find the variance. You extend this table here. Let me create some space here. So when you want to calculate the median, those are the formulas you use, and the mode that is under group data. But under that was under ungroup data, but now things have changed because we're dealing with group data. The next here you add x column, x squared column, f of x, and f of x squared. So the x is the midpoint. You add the lower bound plus upper bound divided by 2. So here 0.5 plus 5.5 is 6 divided by 2, you get a 3. When you square it, you get a 9. 1 times 3, you get a 3. 1 times 9, you get a 9. We go to the next one. 5.5 plus 10.5 is 16. Divided by 2, we get 8. When you square the 8, we get 64. So you start from here. 4 times 8 is 32. Again, you go here. 4 times 64. So that is 16 per 1. 4.5, you get 256. Don't make a mistake of squaring these to get that. You start always from the frequency, multiply by the individual x and x squared. So you do everything else until the very end. I don't need any totals from here. I just need the summation of fx and fx squared. So to find the mean, it's simple summation of fx over summation of af. Find the variance, summation of fx squared. It's a simple formula except that we're just introducing one character, a frequency. Summation of fx to the power 2 over summation of f, everything over summation of f minus 1. Then the standard deviation, the answer we get, square root it. In the coefficient of variation, the same formula, simplifying the CV, standard deviation over the mean times 100. Okay, so this is how we find for group data.